The third part of this question asks how high the table is. So based on the information that we already have, we set up our chart again. So we have delta x and we have y. So our v initial in the x direction, 5.33 meters per second. V initial in the y direction was 0. Acceleration in the x was 0. Acceleration in the y is gravity, -10. We have a time in the x, which is 0.469 seconds. We got a time in the y, also 0.469 seconds. We know delta x was 2.5. The only thing left to find delta y. And we don't have v final for both, so that's coming up. But we want to find delta y. And we know v initial, acceleration, and time. So we don't need anything in the x direction for this problem right now, because all we're asking for is height. Height's a y direction. So if you go through all your equations, since we don't know v final, we're limited, and the only one that we can use is this one, which is v initial y times time plus 1/2 gt squared. So delta y is what we're looking for. V initial y is 0 times time, which I'm just going to leave that because that's going to cancel out anyway, plus 1/2 -10 times our time of 0.469 squared. So 0.469 squared is 0.219 times 10 times 1/2, get -1.998. That's pretty meters. Alright, now the negative, because it's delta y, if we look at our diagram, and this is our table, this level is effectively 0 meters, and this is where we start from. So when you get delta y, you take the height final, so y final, and you subtract the initial height. So for this, since delta y is -1.908, the final was 0 minus y initial, -1.0998, so that means that our object has a height of 1.0998 meters. So y initial is the height, and it's 1.0998 meters.